you use this golden army to build your own instances. Actually, you don't come here. Actually, you already have a golden army and you build it. The same exact process is followed using AWS marketplace as well. Like for example, you want to buy a kind of a software, you can buy the software, install it on your EC2 server and start using it. On the contrary, the companies who sell those software, they themselves bake bole to already predefined bootstrap those servers, those softwares into the specific servers, right? So and then they sell you as a package the server and the software. So these are sold at something called AWS marketplace, where uh, you can buy those server. And if you have your own software, you can build your own customized server and sell it on the marketplace. You can do that also, right? You can sell on your AWS marketplace. You need be just be a part of the Amazon partner network actually. So there are a lot of products, lot of available softwares and everything that you can buy from Amazon marketplace. Now sometimes this is good, sometimes it is expensive. What it depends, because now like for example, if you are buying Juniper or Barracuda, this is again a next generation firewall. So Trend Micro is another endpoint protection security actually. So these are some of the softwares. Splunk is a logging and monitoring tool. So these are a lot of important software that are very much needed for your application infrastructure when you are building in your organization. When they define when they install the software, they optimize it based on the performance. Like if I go, I will just choose 2 CPU and 8 GB RAM. That's enough for me, and I'll know how to manage it for my software, and I know how to do a cost saving here and there. But if I buy from them, they will use 12 CPU or 8 CPU with 20, 32 GB or 60 GB RAM. They'll give you the best one actually, right? So again, you need to know what you want actually. So, but again, it will take off the headache of you installing, you creating of the log and archive folders and log management, all those things. They will take off the headache actually. And again, when you use these AMI, they take care of the patching of it actually. Again, you need to keep updating your installed this one. So it depends
One
how it.
more question I have, Salim, when you showed quick start, you showed AMI. So AMI is AMIs is nothing but ISO files of those servers, correct?
No, these are not ISO files. These are server snapshots.
So what is the difference between snapshot and ISO file? I mean, it is also an image. .iso file is nothing but an image file. And
.iso image is a software image confined file, which is installable. Here it is not installable. Here it uses
uh,
your virtual hardware, a component of virtual hardware with an software already installed on that actually, right? It's compressed package of file with an allocated memory and CPU. It's an instance. I use that term instance, right? So if you see here, the term instance is very frequently used, right? What is an instance? Instance is a term that has been used from almost 40, 50 years. Now, anything which has memory and a background process associated with it, and that is called as an instance actually. Here you all have a memory allocation, you have a computational process, and there is a background process. The background process is the operating system that is running,
but
right?
ISO, when we take an ISO image file, that also have all these things, right? I mean, we allot a memory, we allot a background hardware to
Okay,
it
where will you allot it? Where will you allot it?
on virtual machine
So what, how do you get the virtual machine?
through this through it's a software.
Virtual machine is not a software. I mean to say it is a software behind the scene.
Mhm.
You missed out the session yesterday on how I differentiated on the various rings, how the
Things.
hypervisor is defined.
Yeah.
Anwar, you're clear on that, right?
Yeah. Kind of. Yeah.
Yeah. So there is a different way of hypervisor AWS gives you. Like when we see a raw server like hypervisor 1 or hypervisor 2, bare metal or software upon the operating system, right? So
Mhm.
you have access to the hypervisor 2 kind of an this one. But underlying, there is another bare metal hypervisor which Amazon manages actually before giving the virtual machine to you,
Oh, okay.
right?
Okay.
So there you that cannot be an ISO image.
Mhm.
And if it's an ISO, it would
Mhm.
take a lot of time to get your instance to working state, right?
Now
Because
again,
it
this
takes a
is,
lot
let's
of
see,
time.
this hypervisor 2 again breaks on multiple again. There's another concept called container. Parvez Bhai was discussing the same thing actually. Now, container is between hypervisor type 2 and type 1, kind of a different layer actually, where you, within the hypervisor itself, you create some smaller packages of containers, right? These are again not ISO images. ISO image comes to, those are specific, they are only software images. They do not contain any hardware allocation capabilities. ISO. Okay.
So, Salim bhai, I am a little confused here. I just want to have little clarification. So we have a hypervisor, and on that we have a hypervisor 2, which is managed by Amazon. And on those hypervisors 2, we have the original copy of these Red Hat and all instances, or it is still an image file.
Hold on a minute, let me go back. The context.
So
Are
little
you able to see my screen?
Yeah, so little confusion is what I'm trying to get. We are having a hypervisor which is shared by Amazon, but still we are connected with one of those hypervisor 2 instances where we have an original copy of these operating systems.
So let me.
Because bare metal means that there is no virtual virtuality related to it. I mean, it is directly a bare metal, and then we will have a hard copy onto it.
Okay, now this is your physical hardware. Okay,
Okay.
and this is your first level of communication interface. This is your interface, first level of interface
Mhm.
to your hardware. Okay. Now Amazon has direct access to this physical hardware. This is CPU and memory. Now these are your disk drives, EBS.
Okay.
Okay, these are your disk drive. If you have a EFS, that's another one. Let's consider this is your EFS. This is your shared drive. Let's not get into EFS. However, I'll just put it here. Okay. Now this interface, what Amazon does is it will create a hypervisor, type 1 hypervisor, which is bare metal, and put an operating system on that. Here there is a OS. This is called as the host OS.
Okay.
Host OS, which has way using which you can manage the usage of this physical
Memory.
memory and CPU and
CPU.
everything. Now you are a user, end user here.
Oh, now I have one question here. When you say host OS, it means that it has a hypervisor software on it.
Yes, definitely it will have a
Hyper.
hypervisor software into it actually.
Okay.
It's a,
Okay.
it will be
Now,
a type 1 bare
right.
metal.
Okay. Okay. Now, when user comes into picture, they actually, it can be anything. I can take in one user can take Red Hat, one user can take SUSE, and another can take Windows. now hypervisor will allot certain space and CPU utilization to that particular user, correct?
So what Amazon does is it will create a predefined images called armies, okay,
Mm-hmm.
which has 4 CPU, okay, 16 GB RAM with a Linux instance, Linux operating system already installed into this army, okay. This is called as a army. Now you as a user, you request Amazon saying that I want a Linux operating system with 4 GB RAM memory and 16 GB RAM. Okay. So Amazon gives you this option. Okay, there is available army with 4 GB RAM and 16 GB memory, 4 GB CPU and 16 GB memory. You can use this image and create your instance. So what you do is, this is a kind of a snapshot. There's a concept of snapshot. Like, what is a snapshot? It is a point in time image
Right.
of anything. That is called as a point in time image. At that
Right.
given point of time, you capture, like in your mobile, you take a screenshot of
Right.
your console, right?
Right.
Same way, this is a snapshot of a given point of this one. So you already have a operating system installed, you already have some kind of software installed, and you create a snapshot of it. At that given point of time, you can take an image of it actually.
Right.
Now you can take an image of the instance, your container also, there's a concept called image. So there are a lot of this one. Image is nothing but a this one. Even ISO image is
Mhm.
a point in time capture of a software. It does not have a memory there. So don't get confused between an ISO image and a Amazon machine image or any other image, right? There's a software image, there is a software plus a hardware allocated, confined actually. He cannot make any changes here once he creates an army. He can, now he uses this and builds his own instance, EC2 instance. When he creates a EC2, he will have his OS and he will have his hardware. This is a virtual hardware. He'll have his OS and he'll have his virtual hardware, which is again his memory and this one. Now he will have access to his EBS volumes via this way.
Right. Right. Right.
Via
Right.
this way.
Interfaces.
I'm just trying a bypass here, but it is via this way only.
Okay.
He cannot access, no way can he access this operating system.
Oh.
Okay, now Abdullah comes here, he wants Windows. Now Amazon will give you, okay, I have Windows with 1 CPU, 2 CPU, etc. Right? So he creates his instance using this Amazon machine image. Now again, Abdullah cannot access your hard drive, your hard drive, your hard drive. He cannot access this way.
So basically, here the memory is very constant, and then there is no chance of changing or increasing or decreasing the memory. But when it comes to image file, there is an option of changing, or there is an option of increasing the memory and decreasing the memory. Correct?
No, you cannot. Like for example,
I mean, not this one, not for AMI, but if it is an image file, because this
no,
is not.
even there you cannot. You cannot. These are pre-configured templates. You cannot make any changes.
Oh,
Once you have
right.
created an instance based on the army, now you need more memory, right? So you can request this operating system that I need more memory. So this operating system based on your this one, he can allocate back more memory to you. You need to
Okay.
request here after building the instance. You cannot make any changes to this army. It is
Salim
like your
bhai,
snapshot, mobile snapshot. You cannot make any changes here.
yeah,
If you want to make any changes, you recreate a new army. That will be a new army with here 16 GB or 32 GB RAM. You can recreate a new army, but you cannot change the existing snapshot.
so Salim bhai, you're right. So I was trying to create a new instance, and I use an Army which had 30 GB assigned to it, pre-assigned. Okay, I said, okay, I don't want to use 30 GB. I changed it to 5 GB, and when I tried to launch that EC2 instance, it failed. They said you change you have to go back and change it back to 30 GB.
Because the capacity of that particular instance needs that much in a memory
Yeah.
or more than
Right,
So,
right, yeah.
5 GB.
That's
so again, we need to understand the underlying differences. This is dynamic. You can modify the EBS, the storage, what is required. But this part, the operating system, memory, and CPU, these are, this constitute an army. Now, when you create a snapshot, you can add your EBS volume to this army. You can do that. This is kind of, this is the concept of backup and recovery. When you are backing up your servers for mitigation, disaster recovery, these are concept every organization has to well plan. They have to well plan for disaster management, disaster recovery. They need to take backup of their application servers along with the associated EBS volume. Few companies, they only take snapshots of EBS volume, and but that is not a disaster recovery plan. You need to have an army associated with it. You create a backup plan when a server breaks. So this army gets created every 1 hour, every depend upon your strategy. You can create an army every 1 hour. You can create an army per day or every 6 hours, 7 hours, 8 hours. You can automate a solution and add 4 GB memory, 4 GB CPU, 16 GB RAM with this EBS volume where your crucial data is stored, your operating system is stored, your Oracle database is stored, or a WebSphere, your .NET application, your Golang application is stored here. All those things is already defined here. So if a server goes down, immediately you have a backup army, a snapshot of it. You take this army, rebuild a new instance immediately. Now, what happens to that 1 hour kind of the logs that has been lost, actually, the transaction? Now, that those again can be recovered actually based on what kind of a, like database has its own capability wherein it takes kind of using the transactional logs, you can retrieve that data of 1 hour right between that. So there are multiple strategy, multiple thoughts have to be, good thoughts have to be put by an experienced architect, how he designs the application infrastructure. But armies are very important for disaster management, disaster recovery, backup and recovery. All these are very important. Clear?
Yep. Yep.
yep.
Limbai,
Yeah.
what is a container, and can we have our own custom AMIs?
Yes, you can have your own custom AMIs. Now, container is a kind of a new architectural framework that they came out starting to about 5, 6 years, 7 years back. So there is something called Docker that is a predominantly used container. So what it does is now you have an operating system here. In this operating system, you build your applications.
Mm-hmm.
Like I have the virtual hardware here. Now this is your Kadir's, Kadir, your server, okay, your instance.
Mm-hmm.
Now you have an e-commerce application, okay, on
Mm-hmm.
.NET.
Mm-hmm.
.NET पे तुमने e-commerce application बनाया है, and underlying there is an operating system.
Mm-hmm.
And the version of that not .NET would be a legacy one.
It does not matter. It really
Oh,
does not matter.
okay.
Whatever operating system you have, whatever framework you are using, .NET, Java, Python, anything, it does not matter actually. Now, what happens here is, now when you are, the whole concept of containerization is it came into existence because of easy management of delivery and shipment of it actually. So if there are two developers developing,
Mm-hmm.
okay, developer one, developer two,
Mm-hmm.
अब क्या करते हैं तुम्हें एक एप्लीकेशन वन एप्लीकेशन व्हाट यू डू इज यू ब्रेक अप इनटू डिफरेंट मॉड्यूल्स ओके अब मॉड्यूल 1 मॉड्यूल 2 ओके module 1 module 2 you give module 1 to be built by developed by developer 1 module 2 you give it to developer 2 to build.
Okay.
Now these are part of a single package or an application. It may be a package or an application, single one. Now this cannot go into production until both of them complete.
Right.
There may be a dependency that M1 or D1 also has to complete, D2 has to be also complete actually.
Right.
So this was kind of a monolithic approach where the entire package has to be presented for a successful application deployment and application availability.
Okay.
These applications were called as monolithic applications.
Okay.
Now they came out with the time taken for this and dependencies was enormous. So what they came out with something called as a microservices architecture.
Mm-hmm.
So Docker was the first company. What they did was they created these modules as containers. Now this container will have all the software in it. छोटे छोटे मॉड्यूल बना. So D1 will have independent capability to make changes to this production system, to the live application. He is not dependent for his changes to go in. He is not dependent on D2's development.
Okay.
So
what
these
does this mean?
modules were further broken down as containers or container images or images से container build करते हैं. Same concept है EC2 का भी. So container will contain an underlying operating system, its application infrastructure, and his module is separately built into it actually.
Okay. So
So
basically,
this eased the development life cycle. It reduced the time taken to the life cycle. It reduced the dependencies. It gave a more kind of a model view controller का एक framework बोलते हैं सर software development में. It gave a new approach, new flavor. Security management is different. So a lot of advantages to it actually. So that is how it came out as a container. And this, because it contains an operating system, it contains a kind of a complete package of the application that you are deploying, right? So this can be shipped like anywhere. It can be taken. It's portable. It's called portable. Your application, it's very portable. Your deployment micro application is portable. So you can take it, deploy it in anywhere, any places actually. You can take that deployment in deployment server, the same package you can deploy in this one. Like for example, the advantage here is, for example, you are building on a .NET framework. Now you are using .NET framework 4.5 and you build this module, right? In production, the development framework is 3.5. When you deploy your 4.5 your application that you have built on production system, this will not work. This will crash. The frameworks are now container में क्या होता? You use already a .NET framework 4.5 and you deploy it here completely as a container. That way you have the underlying framework, the required software to run, the required drivers to run, all those things will be pre-baked.
okay. So Salim bhai, the containers, how are they divided? समझ लीजिए I just wrote the bare skeletal code and then I'm just depending on other people to provide different libraries and stuff like that.
You are not dependent there. You create your own libraries. You base image ले लेते हैं. Already एक existing base image बना को मैं अब जैसा AMI है उसी तरीके से तुम ना .NET framework का बना को और बेस जावा के लाइब्रेरीज यूज करना या .NET के फ्रेमवर्क लाइब्रेरीज यूज करना, ये पैकेज GitHub का पैकेज ये यूज करना, ये गेट इग्नोर करना, ये पूरा पैकेज बना को तुम ना D1 को भी डालता हूँ, D2 को भी डालता हूँ. So these are called container images, base container images. बना को डालता हूँ, उसके ऊपर तुम्हें डेवलप कर को तुम्हें वापस मुझे देती. मैं वो तुम्हारा कंटेनर ले को वो इमेज ले को मैं अलादा कंटेनर इंस्टेंस बना को deploy कर डाल दो. It's a kind of a good concept. If you are getting into development, we can have one session on this one sometime.
Yeah, sure, definitely for
So,
me.
Levi, security, how does is security policy come to play here, especially when you open a port or something?
Right. So that is a very good question, actually. Now, there are a lot of security concerns and concepts which lot of investigation is still happening in many organizations. The biggest security is because this container runs on its own operating system and own this one. It's a separate entity. The the biggest concern is OS level पे तुम्हारा endpoint protection का जो for example antivirus चल रहा, right? So your log monitoring, all those things, that capability are not extended into the container. So this is a separate layer. Your operating system is a separate layer. Your container framework is a separate layer. It cannot take whatever is running in the operating system.
So are we saying the containers will not have the firewall that OS is having?
Yes, it will not have the firewall where OS is having. So the firewall AWS gives you is the firewall between here, your communication to your EC2 instance. It is not, it is least concerned about how you manage your container security. It is your internal application architect's design,
So
how you provision this one, how you give connection. Hold on a minute. We are timing out in 10 minutes. We'll reconnect back. Okay. So there are some softwares that have come up, and most of the other companies, they are rebuilding their softwares to cater to the security needs for these containers. It's still growing. Even now, if you see for antivirus, it still does not provide. Very few, one or two companies have come up with a solution, like those kind of things actually. Now, there are a lot of security concerns that you need to play a role, like whatever this guy who has baked his container image, he may not put in his hacking code, like he does not have any vulnerable packages within there which can be exploited. So those kind of scanning is still a kind of evolution of how do you scan, how do you see that there is no hacking code or there is no vulnerable code inside it. So all those things have to be worked upon. Okay, you are talking about security groups are a kind of a firewall between your instance and communication to this instance. Why somebody else, somebody trying to reach here, right? So this is now there are two security groups again. One is a security group at the instance level which you manage. There is other security group which prevents you from accessing this hardware directly or the network interfaces underlying you using this CPUs. So that security group is managed by Amazon. You don't have access to that security group. You have access to the security group of your operating system, of your EC2 instance. This image is too much scrambled. I'm overwriting it. If you want, I can create a new one, but if you're fine, we can move with the next, this one.
So, Salim, just to reinforce that concept, your security group is between the army there and your EC2 instance. And what's the other thing, the little box? That's your EC2 right at the top, and then you have the army.
So our security group is between, now let me draw this.
between internet and your instance.
Now this is called VPC, Virtual Private Cloud. This is your entire network.
Right.
Okay. wherein you can build all your servers, your storage, your anything and everything. What you build it within your infrastructure. This is your infrastructure. This is called virtual private cloud. Okay. So
Yeah.
you create a virtual private cloud in your AWS account. Now, a bigger concept is this is your AWS account. Okay.
Okay.
Under that, you have your virtual private cloud, which is your network infrastructure. Under this network infrastructure, you have your various servers, appliances, data, any kind of everything. For example, अब तुम्हारा on premise रहा तो printers भी रहते, lot of things. Same way you have many of the appliances. There are many things that are called appliances which you use within this VPCs actually. Anything that communicates using your Ethernet cable, right? So it's a part of your network. Same way, anything that can communicate using your IP addresses, it is part of your VPC. Okay.
Yep.
So now this is your virtual private cloud. Under virtual private cloud, you have something called as subnets. These are your subnets. You break your virtual private cloud for easy management. Like you give this subnet to somebody, one development team, you give this subnet to one development team, right? You give this subnet to database team, you give this subnet to application development team. So as to easily manage, there is something called micro segmentation in security. Okay, to bifurcate that one person does not access to another. So micro segmentation is more in deep actually, but I'm just touching on a very high level. So you create various subnets to easy manage. Under these subnets, you create your server. These are your these rhombus chai here. These are your server, EC2 instance server. Now, any communication that goes and reaches to this server, there is a firewall here. This firewall will allow access or prevent access to the server. This firewall is called security group. The communication to this server may be from this server, maybe from this server, maybe from this server, or from this server to external, any. So there is something called inbound. Inbound is what is coming in or going out, or a communication from this server to the world, internet, or your laptop, which is again part of your world, or any other AWS account. There's another AWS account, there's another server. So again, this has to communicate to other server.
And what about the rules which are created by your laptop or the internet, or anything which is external to AWS account? What
So
are what about the firewall rules created by those particular server devices which are created out of your AWS account?
So
Will that
firewalls are at multiple layers. So there is a concept called defense in depth. Okay, uh, concept in security. What it means is you have multiple doors that block your access. There are multiple doors you need to open to enter. You have a firewall here, then you have a firewall here at the subnet level. Then you
right?
have a firewall at the VPC level.
Mhm.
So you can have multiple security guardrails or multiple doors to prevent anybody, somebody accesses, yeah, access kar liya abhi. Oh, somebody is able to penetrate here.
Mhm.
Again, there is a second check. He has
So,
to penetrate here. Then there is again third check. He has to penetrate here. This
Oh,
is again at the network layer. You
mhm.
also have something called as an access management layer, where you again you prevent somebody access unauthorized. You don't allow an authorized access.
and this all won't work if you have a container within instance.
Now, container again within instance is your responsibility. So if he has a AWS gives you provision up till here. Once you have access to the container, Then getting into the EC2 instance, getting into the container is a separate security firewall. There is a separate security firewall that you can manage there actually.
So are we talking about Kubernetes containers which AWS provides, or if I have like Kubernetes on my own instance managed by ourselves?
Yes, Kubernetes, ECS, these are container provisioning and managing frameworks actually. But underlying, it is still the instances itself. Containers are nothing but it can Docker container. Kubernetes also is a Docker container itself. Kubernetes is a framework which helps you manage provision, deprovision, these the container instances.
So,
That's what
Salim
I'm
bhai,
telling you. This is out of scope of this one, but I'm telling you for the understanding. We can go deep dive, and if you want to build a container, we can do that also. It's very simple in building containers, whether it is a AWS gives you two provisions to create containers. You can build Kubernetes containers or you can build ECS containers. ECS is proprietary to AWS. Kubernetes is a product of Google actually. Kubernetes was initially open source. Google took up that open source and started developing from that. Okay, is this